So yeah, this question asks for us to find the range of this data set. So I'll do this one as an example, and then you guys could try 1B here. Alright, so to find the range, it has a simple formula. It's going to be the highest value minus the lowest value. So if I look at my data set, I see that 26 is the lowest, and it looks like 80 is the highest value. So we can get a sense of the spread of the data just by subtracting them two. We'll do 80 minus 26 makes 54. Alright, so you can try it for 1B. It says a corporation hired 10 graduates. The starting salaries in thousands of dollars for each graduate are shown. Find the range of the starting salaries. I'll let you try it for a minute. Okay, so if I look on the data set here, I think 37 is the smallest and 47 is the largest. I'll put it in thousands of dollars, so the range will be 47,000 minus 37,000, which is 10,000. And it's a fairly simple explanation of the spread of the data. A standard deviation, though, is a little bit more complicated. And I'll try to explain it with just a similar example to this one. So you guys can try this one, but I'll do just different numbers over here. So there's a lot of different drawings of the data that we can do. So A is 0. B is 1. C is 1. D is 3. E is 5. And F is 5. And G is 6. Now we want to find the mean of our data set, which is X bar. So X bar has the formula sigma X over N. So we just have to add them all up. And then divide by N, which is, let's see, there's 1, 2, 3, 4, 5, 6, 7 data pieces. So we see that N is 7. That gives us a mean of 3. Now I can draw the mean as a horizontal line on my picture. That's the mean there. And we can see that one of the data pieces is right on the mean. That would be the middle 3 there. But the other data pieces, they have what are called deviations from the mean. They're different from the mean. And you can show those differences with a vertical line here. See how different they are. So this one's got a difference of 3 from the mean. This one has a difference of 2. This one has a difference of 2. This will be a -2, -2, and -3. Those are deviations, they're called. We want to find an average, a sort of average of the deviations. That's what a standard deviation is. So, to get started calculating it, you just need a column for X and a column for X bar. And then we can have X minus X bar. And we'll just list every piece of data that appears in our data set, with repetitions if there are any. So we got 2 1s, so I want to make a row for both of those 1s. 2 5s, so I'm going to make a row for both of those 5s. We're supposed to put the mean in the middle column here. And since there's only one mean for the whole data set, you just repeat the 3 all the way down. Okay, then what we want to do is subtract straight across. So we want to do 0 minus 3 first to get negative 3. Then we'll do 1 minus 3 to get negative 2. 1 minus 3 makes negative 2. 3 minus 3 will be 0. 5 minus 3 is 2. 5 minus 3 is 2. And then there's going to be a 3 there. So this is the sample. This is the mean, and this column is for the deviations. Alright, now we want to make one more column, x minus x bar squared. This is called the squares of the deviations. Alright, so all we have to do is take the value that we get here and then just multiply it by itself. So we're talking about doing negative 3 squared. You have to have the parentheses around there. It's a common mistake for people to write something like that. So we do want to put parentheses if you do enter it into calculator. And then you'll get a positive value when you do. So this will be 4, 0, 4, 4, and 9. Once you have those, you want to find the sum of that column just by adding them up. So add the 9, the 4, the 4, the other 4s, and the 9. So that gives me, I get 34. Did you get 34? Yeah, 34. Okay. Now, the reason we do that is because sample standard deviation has the formula S equals square root of the sum of the squares over n minus 1. So the whole reason we make that table is so that we can get a value that we can plug into this numerator. And now we have it. So we can type in square root of 34 over n minus 1. For my sample, I used an n of 7. There were 7 data pieces. So we'll do 34 over 7 minus 1, which makes approximately 2.38. Now if you look at the deviations, you can see that we've got a deviation of 3, a deviation of 2, here's a negative 2 and a negative 3, and then there's one value that doesn't deviate at all. What this is like is it's supposed to be like an average deviation. It's not exactly technically an average because we are squaring and then square rooting. It would more be called a root mean square type of average, but that's what it is. It represents the spread of the data. Now there's one more picture that we'd like to draw for this, and that is a frequency histogram. Alright, so in a frequency histogram, we want a bar graph showing the data. So we'll let the x's be on the horizontal, and then the frequency can be the vertical. But let's make it into what's called a relative frequency histogram this time. So the difference is, to find relative frequency, you do f over n. And you can put it in percent form if you do times 100. Alright, so here's, let's say 100 up there. And there's 50, and we can count by tens. We'll put all the different values that we get in our data down here. So there's a 0, there's some 1s, there's a 3, a couple 5s, and a 6. And we just want a bar graph to show our data. So one of the things that we have to do in order to make this bar graph is create a frequency distribution. So this goes back to something we did in the past. We need a column for x and a column for f. So x is our sample. So that's 0, 1, and 3, and 5, and 6. These are the values that appear in my data. Notice here I don't do repetitions, because I'm going to take care of the repetitions with the frequency column and say how many times those values appeared in my data set. So there's 1, 0. Let's just put that there. There are 2 1s. So let's put a 2 here. There's just 1 3. There are 2 5s and 1 6. So that's my frequency distribution for the data. But if we want to make a relative frequency histogram, let's make a column for f over n. And that is, of course, relative frequency. Alright, so there are 7 pieces of data. So my first one's going to be 1 out of 7. That's 14%. Then we have 2 out of 7, which is about 29%. And you just keep calculating them like that. Until you have all your percents. And those percents will become the heights of your bars. So there's only 14% zeros. The 1s occupy 29% of the data. There's a single 3, which is 14% of the data. 2 5s, 29% of the data. And then just 1 6. So that's a histogram, which is a visual picture of our data. And as we can see, there's a little bit of spread to the data. Alright, and this value tells us how much. 2.38 on average. So the difference between the 3 and the 5 is 2. The difference between the 3 and the 6 is 3. So what that number is saying is most of the data would differ by no more than 2.38 units, is what it's saying. Alright, hope that example makes sense. I know it's a lot to throw at you, but now you can try it on number 2 here. Okay, so first thing I want to do is just create a column for x. Yeah, we'll find the sample standard deviation of this data. So I need an x column and an x bar. And then we'll do x minus x bar. Let's list all our data. 0, 2, 2, 4, 4, 4, 4, 4, 6, 6, and 8. So I got all the data with repetitions in there. I'm going to find the mean of the data using the formula x bar equals sum of x over n. So just add up your 0 plus 2 and all that. The sum comes out to 44. There's 11 data pieces. So I do get 4 out of that. So our mean is 4. So then we just have to subtract straight across. 0 minus 4. That gives us -4, -2. And just keep going with that subtraction. Okay, once we have those deviations, we'll now square the deviations. So that's going to give us 16, 4, 4, 0, 0, 0, 0, 0. Then we'll have 4, 4, and 16. Let's get the sum of the squares. That comes out to 48 if you add all these values together. So we've got our formula for sample standard deviation, which is the square root of the sum of the squares divided by n minus 1. We'll put our 48 on top because this 48 needs to go here. Then we'll divide by 11 minus 1 because there's 11 data pieces. I get 2.19 out of that. Did you get the same as me? So next, we want to create the frequency histogram so we can get a visual picture of what the data looks like as a bar graph. And so we want to start with a frequency distribution. And then look at all the numbers that appear. We've got 0, some 2s, some 4s, 6s, and an 8. And then their frequencies are that there's 1, 0. We've got 2 2s. I count 5 4s, 2 6s, and just 1 8. Then we can find those percents by doing F over N. Then we can see how tall the bars should be. So since there's 11 data pieces, we're talking about 1 over 11, which is 9%. So the 0 there occupies 9% of the data. Then we got 2 over 11. 2's represent 18% of the data. 4's represent 45% of the data. That's a big component of the data there. Almost half the data. And we get 18%, and 1 over 11 makes 9%. Now, we want to let the bars have a height that's equal to their percents shown in the table. So 0 should have a bar height of 9%. 2 should have a height of 18%. 4 would have a height of 45%. Yeah, 6 has a height of 18%. And finally, 8 will have a height of 9%. There we go. Now we have a nice visual picture of our data. We can see how spread out it is. And according to the mathematics, most of the data lies within 2.19 units of the mean. Because of the symmetry of this data, the mean is 4, so that's right here.